Hey everybody, today we're going to be talking about statistics, and we're going to start out with descriptive statistics today. This is nothing that you should be afraid about, and certainly not something that you need to worry about. But let's get started, and make sure you, before you start this, have read through the first 2 pages of our packet that we picked up today. Those will be terms, important terms and definitions that we'll cover in this unit, just so you can refresh yourself if you've already had stats class, or you can become aware of some of the special terms that we'll use in this unit. You should also have open pages 3 and 4 that have these PowerPoint slides so you can follow along. And feel free to pause or back up if you need to add some notes to your packet. So let's get started here. So we're looking at descriptive statistics today, and when we talk about statistics, it's really nothing to worry about in AP Psych. It's really rather elementary information that we'll talk about, and it's just a numerical description of the data that we derived from our research that we talked about in our last unit on research methods. So think of it as numerical storytelling, the numbers that we get when we do a significance test or other types of statistical analysis. Just kind of tell the story about what happened in our research. And we want to be able to do that so we can publish and let other people know and look at our data so they can see what happened as well. So remember, all data that can be measured or reported in numbers can be categorized into one of 4 types of scales. So remember these, or this acronym NOIR. That stands for Nominal Scale data, and we'll talk about that separately. Ordinal Scale data, Interval Scale data, and Ratio Scale data. These are all represented by numbers, but the numbers don't mean the same thing in each scale. So let's take a look at each of these scales separately, and we'll be able to figure out what kind of conclusions we can make depending on which scale of numbers we're using. So if we look at the nominal scale, nominal numbers are used to group or categorize. So this is often called categorical data. I remembered it as nominal scale because the number really names something that we're looking at, so it doesn't really have mathematical computational capabilities. For example, uniform numbers are an example of a nominal scale. Your driver's license number, your social security number, numbers really are just identifying a position or a place or a thing. We could also score political views on a survey. So on a survey, you might have the opportunity to have strongly agree, neutral, disagree, or strongly disagree. And when we do an analysis, we might apply a number to each one of those categories so we can represent it in a chart. Now notice on these different uniform numbers that Clay Matthews' number of 52 is way higher than Aaron Rodgers' number of 12. That doesn't mean he's 40 points higher than Aaron Rodgers or that he's better than Aaron Rodgers. It just means that might represent a position they play or just to identify that player on the field. So do think about what conclusions we can make and what conclusions we can't make. We can't compare the numbers together as being better or worse. Now, ordinal scale, as you might guess, ordinal means order or rank order of place. So you can put things in order of better, faster, smarter, stronger. And some examples of this might be basketball polls where, Wisconsin's ranked pretty high right now, 4 maybe. And that means they're 4 points higher than the 8th ranked team. But that doesn't mean they're twice as good. And it doesn't really tell us how much better the number 1 ranked team is than the number 20 ranked team, because certainly when they play, a 20th ranked team could beat a number 3 ranked team. Some other examples might be Mohs hardness scale in geology or your class rank. It doesn't tell you how much better somebody is, it just tells you what order you finished. The college basketball poll is probably one of the more famous ones coming up as we get into March Madness. And the order you finished in a race, for example, would be order or an ordinal scale, but it doesn't tell you how much faster somebody finished. So the intervals are not necessarily equal. So if you think about what conclusions we can make here. Now an interval scale is interesting because they involve consistent units of measurement and equal spacing between the units of measurement, but it has no true 0 point, which means there might be negative numbers. Example, measures of Fahrenheit or calculus. Certain scales in psychology might have equal intervals, but not necessarily an absolute 0. So if you think of an interval as a definitive length of time or of another category like temperature, and an example might be the difference in 4 degrees between 50 and 54 degrees is the same difference as it is between -4 and 0. But you can't say that 60 degrees is twice as warm as 30 degrees because there's numbers below 0. And there's our example. Now, a ratio scale is probably the superhero of all scales because not only is it an interval scale, it is also a ratio scale, which means you can do some really cool comparisons because there is an absolute 0 point. There's this true 0. There's no weight or no measurement. So it typically deals with physical scales, like how fast you were going. Now, because it has a true 0 point, because a car can be standing still or a person can be standing still, that a car going 60 miles an hour can be compared to twice as fast as a car going 30 miles an hour. You can have 0 height, so somebody who's 7 feet tall is twice as tall as somebody who's 3.5 feet tall, or somebody who weighs 100 pounds is twice as much as somebody who weighs 50 pounds. And even in measurements like tablespoons and teaspoons and cups, so a quarter cup is half as much as a half cup. So we might look at a scale and say somebody weighing 150 pounds weighs twice as much as somebody weighing 75 pounds. So it is an interval scale, but it is also a ratio scale because it has a true 0 point. So I want you to pause after our next chart comes up because we're going to look for how many different scales of measurement can we see in some hockey statistics. So you can pause here and take a look. You want to define the term as you use it in true FRQ format, and then explain how the scale of numbers or the column of numbers that you see would represent one of the scales. So you can pause here and look at this cool, the last time the Badgers won the NCAA hockey championship, and we'll talk about this in class the next day we meet. Good luck.